Hey YouTube, welcome back. Today is the second approach of solving this problem. Problem number 80, remove duplicates from sorted array. It's the second version. In the previous video, we solved this problem by popping up on the unwanted elements. Today, we'll try to overwriting them. So let's just reset everything and let's just read the problem and let's just think about the solution that we're trying to do. Okay, so we are given an integer array called nums sorted in non-decreasing order. Remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should keep the same. Since it's impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array called nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k elements of slots of nums. Okay, so we have this array as example, and we have already the 2 has been duplicated twice only. This is once, but we have 1 duplicate 3 times, so we need to remove 1 or overwrite 1 and return the k elements, how many elements left, which is 5, the length of the the remaining elements. So by this problem, we can just let's just try to think how we can do it. So let's create like a j element, and this will be using an indexing to loop through the array. And I will create a count array. No, let's create 1, not 0. A count array, which will be 1. This will try to count how many occurrences for each element. And I'll create a while loop, and I'll say while, no, let's make a for loop this time. Let's say for loop let I equals 1. Okay, and I less than nums dot length and I plus plus. And let's just try to make it let's just see if we have a duplicates or not. So I would say, because it's a sorted array, we only need to compare each element with its previous value. So I'll say if nums of I equals nums of I minus 1. If that was the case, we increment the count by 1. If that wasn't the case, we reset count. Okay, so let's try to do this also. So let's say that we increment the count by 1 and the count is equals to 3. Like for this one, for this example, the count will be equal to 3. So we'll say, okay, if count, let's say if let's you know what, let's do it the other way around. If the count smaller than or equal to 2, let's do it the other way around. We could make like nums of g will equals nums of I, and we increment g by 1. So basically we make sure that we overwrite the unwanted, the unduplicated, and we return j in the end. So let's just try to run it and see it will work or not. It did work. Okay, let's try to discuss how we did that. So for example, we define a function we call remove duplicates, and that takes an array called nums as its parameter. After that, we initialize j, and j the variables which will be like our second pointer. The first pointer will be I. Okay, and we count the duplicates element here. And the count the duplicates element. After that, we iterate through elements of the nums array, starting from the second element, which is index 1. Inside the loop, we check if the current element of nums of I is equal to its previous element, which is nums of I minus 1. If it's duplicates, we increment the count variable. If the count variable if the count variable is greater than 2, it means we have encountered more than 2 duplicates elements in a row. So we ignore the extra duplicates. Okay. For a count less than or equal to 2, we copy the current element to index j in the array, effectively overwriting the element of at the index. That means if we have a duplicate, we overwrite the duplicates also. And after that, we increment j to move to the second pointer forward, and we continue iterating through the array until we have checked all elements. Finally, we return the update length of the array, which represents the length of the modified array with at most 2 duplicates elements, because we overwrite it. So basically, let's say that we are here. Let's talk about this one. So we start J1 and I1. So we start at here, and we compare if it's equals to previous. Yeah, that's right. So we increment by 1. So after incrementing by 1, we'll say if it's equals to count smaller than or equals to 2. Yeah, that's right, because count right now equals 2. So what we'll do, nums of j, which will be this one, will be equals nums of I and j plus plus. They are equals each other, so no problem. So we have this one here, and you have right now the the count will be 3. So when the count be 3, we ignore this if statements and we continue looping. Okay, and we are right now here. So we say that if 2 equals if 2 equals 1, because previous that's not the case. So we set the count to 1, and we overwrite this 1 by 2. So what we say is that nums of j equals nums of I. So this will equals 2, and this was already at number 2, so it will be number 3, and you continue so 1 so 4, and you override the 2 also here with 3, and you will return this, and we do not care about all the other elements. So yeah, that's it, and this is how you solve it. I love 2-pointer solutions because they make sense. They make sense, a lot of sense to my head. So yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video, and see you guys in future problems. Before that, let's submit and see it will work or not. Okay, it did work, but it's beat 85%. The previous one beat 96. But I don't know why, but I love this more. So anyway, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.